Hello SGD, Sacred Geometry Decoded. This will be part 13 of a series looking at understanding the Great Pyramid and the ancient sciences. Previous episodes, for instance, were looking at Vitruvian Man and connections between ancient measure systems, including the allegedly modern English foot, but as Vitruvian Man shows, the actual number of feet for a man is much closer to 6.9 or 6.8714 feet, which is the number of English feet, or 2.0944 meters equals 4 Egyptian royal cubits, the ideal man. 4 cubits being the definition of a ideal human, from your fingertip to your elbow. Which brings us to the connection between the meter, the Egyptian royal cubit, and the allegedly modern English foot. So a meter plus an Egyptian royal cubit plus 1 foot equals 5.9987 English feet. Which is a nice thing because a 1 meter pendulum, I'll get into more into this because there are variations on a 1 meter pendulum, and the information and the margins of error actually encode some beautiful connections. But just for the moment, a 1 meter long pendulum swung at 30 degrees, which is not an arbitrary angle. That's just like a grandfather clock. It needs to be swung at a shallow angle. But a 1 meter pendulum swung at 30 degrees, which has been for centuries the accepted maximum angle to swing a pendulum. That 1 meter swung at 30 degrees equals pi over 6 meters, or 1 Egyptian royal cubit, which equals 1 second, which is, for example, 86,400 seconds per day, which is, I would say, a much more elegant definition of the scale of the Great Pyramid to the size of the Earth. But that to the side for the moment. 1 Egyptian royal cubit, pi over 6 meters, Old Kingdom cubit. So the meter, the second, and the cubit come together. The meter, the Egyptian royal cubit plus the foot essentially equals the ideal modern imperial measure of 6 feet. However, so the relationship between the meter, the Egyptian royal cubit, the allegedly modern English foot, and 1 second of time is extraordinarily close. But 1 meter, 1 second, 1 Egyptian royal cubit, the connection between the idealized man of 4 cubits, or what is now described as feet, but the actual relationship between the foot and the human body is not 6, but so it's the cubit of 4 feet, 4 cubits, or 1, 2, 3, 4, 5, 6, 7, 8 span or head. But so 6 feet is the 1 cubit equals 1.5 feet. But meter plus cubit plus foot equals 5.999 feet. But let's look at that. And so I'll link in the description to Alan Green and some brilliant work that he's done on this. He was the one who showed the connection between the meter plus the Egyptian royal cubit plus the foot. And it is ever so slightly short of 6 feet. 0.0013 feet, or 0.396 millimeters difference. This error has some very interesting links, which brings us back to the Salomon Stone, which is at a 3:2 ratio, the vesica, just like Khafre's pyramid. The base length of that 3.84 feet is 4 ionic feet, and that 3.84 feet equals the square root of 5 Egyptian royal cubits within 0.33 millimeters, and that's this margin of error. That's a difference of 0.066 millimeters. Now the square root of 5, how does that, is an important feature because it connects to the golden ratio, or phi. Phi equals the square root of 5 plus 1 over 2, square root of 5, and the golden number of, basically it's the best way of doing it. This was also linked to the pentagon and the pentagram and the golden number. Now phi cubed is also equal to the square root of 5 plus 2. And so 4 ionic feet, there we have 1 ionic foot, there we have a Doric foot, and just like the imperial English system, 1.5 feet equals a cubit, and so 1 ionic foot plus 1 Doric cubit equals 2.56 feet. 256. So if you're into your music, you'll get that as well. Now, that's 3.84. 384. Divide that by 2, you get 192. This is 256. It's Pythagorean music tuning. But we also have in the Salomon Stone the common Greek foot or the English foot at least 500 BC. This will be an important feature mentioned earlier. We'll be coming back to that because the allegedly modern system of measurement connects to multiple ancient systems of measurement. For instance, the ancient Indus Valley civilization in Harappa, Mohenjo-daro, and the Royal Babylonian scale of measure, or the Saxon foot, which was before the English foot that we have now. The Saxon foot was 1.1 feet. The Mohenjo-daro, Harappa, or Indus Valley civilization, their unit of measure was 1.1 feet, and the Royal Babylonian scale 1.1 feet, or 13.2 inches. But at what we have an extraordinary symphony of coincidence. But back to the golden ratio. Why is phi, or the golden ratio, so important? So 1.618033988 is the perfect definition of phi. It's a little bit more complex than that, but let's geometrically speaking, that would run on lots and lots of decimals. But phi squared equals phi plus 1. So 1.618033988 plus 1 equals 2.6180, which is phi squared. Phi plus 1 equals phi squared. 1 divided by phi equals phi minus 1. 0.618033988. This only happens with phi, and this is what makes this golden number, the golden ratio, so important. You'll see it whether it's in pine cones, pineapples, galaxies, hurricanes, shells. This is it's built into nature. It's not just a mathematical curiosity, it is one of the underlying constants of nature, and that's why the square root of 5 Egyptian royal cubits in the Salomon Stone and the math connected to that, it's just beautiful math. It's just the only way to really put it. So back to Alan Green noting the relationship between the allegedly modern meter, the Egyptian royal cubit, and the allegedly modern English foot. So that's a difference. So the meter plus the Egyptian royal cubit plus the foot, if you go into your modern conversion or calculator, put it together, 5.9987 or 999 feet. The difference between there, so the number might look special, but that's the width of a human hair. If I was to insert a human hair, that's the margin of error we're talking about. Which brings us to 6/5 ratio, this very important geometric ratio. And so a meter plus an Egyptian royal cubit equals 5 feet within 2 human hairs. Meter plus the Egyptian royal cubit plus the foot equals 6 feet within 3 human hairs, which is, again, unless you're working in a modern laboratory with microscopes, quite high-powered microscopes, that level of precision is extraordinary. So 6/5, one example of what makes this so special is that, well, hexagons are stackable, 6-sided, just like why beehives are made of hexagons. It's the most efficient use of material and space on 2 dimensions, but in 3 dimensions, for instance, to make a soccer ball, you need hexagons and pentagons, 6s and 5s. Another example would be, for instance, this is the Merkine, what they call it, the Merkine Pyramid in Lithuania, but these geodesic domes, what you really have is, it looks like triangles, but what it's also a series of pentagons, a series of hexagons. But to get the hexagons to fit together in 3D, you need at least 1 pentagon as a keystone. So just like the soccer ball, here we see the same thing. You need a pentagon, at least 1 with these hexagons to fit these shapes together. So from the 2-dimensional to the 3-dimensional, we'll be getting into that because the pyramid is 1, 2, 3 dimensionals, and the geometry contained therein is just beautiful. It's perfect. At the Osiron, This is one example of the flower of life, and what you really have here is another example of a vesica. That's the inherent geometry underlying all of it, which creates a series of hexagons, 6 sides over 6. Which brings us back, so this is the seed of life. 6 circles around the 7th creates a perfect hexagon. This is Euclidean geometry, perfect geometry. It's one of the curiosities of geometry, is that 6 circles of equal radius around the 7th perfectly divides the circle up into a hexagon, or 6 units. So that's why it's not arbitrary. This is like nature leads us to this. This is why the hexagon is on the poles of Saturn. This is why beehives have the hexagon, because it's stackable and it's perfect and it's the most efficient. Nature has told us it just is, it has to be. It's built into nature, which brings us back to the 5 feet to 6 feet ratio. Meter plus meter plus the Egyptian raw cubit plus the foot. So that geometry, as in the Osiron and well across time, across the world, links us to the meter and the Egyptian raw cubit. So I've just, that central circle, that's what we have here, dividing the circle up into 6, 1 meter diameter. Each 1/6 of that circle equals 1 Egyptian raw cubit. The meter and the cubit are linked, and this is just the beginning. It's so much more into this, but let's begin with a 1 meter diameter circle, which creates the hexagon. 1/6 of that is an Egyptian raw cubit, so the meter and the Egyptian raw cubit. So 1/6, so the other 5, so 5 over 6 times pi equals 2.617994 meters, which brings us back to phi, the golden number. Phi plus 1 equals phi squared equals 2.61803398. So I've just rounded it off to 34. So 2.617994 meters. Phi plus 1 equals 2, or phi squared equals 2.618034. That's a difference of 0.04 millimeters, or 40 microns. There's a typo there. The width of the thinnest human hair is the difference between phi squared meters and pi over 6. Sorry, 5 over 6 times pi meters. So 5 over 6, that's 1, and then we have 5, or 6 and 5. Okay, so now the meter plus the Egyptian raw cubit plus the foot. So for instance, the diameter of a circle, 1 meter, plus 1 Egyptian raw cubit equals 5 feet. 1 meter plus 1 Egyptian raw cubit equals 5 feet. Again, splitting hair, less than, or 2 human hairs would really be the difference in there. Which brings us to the Great Pyramid. So an important feature about the pyramid, most often it's described as either a square or a triangle. No, the pyramid is a pyramid. It's a three-dimensional object, and the best way to understand it is to look at it as a three-dimensional object. So you stand at the corner of a pyramid, the most you'll see, the maximum visible base of a pyramid, and I'm using the idealized measures. We'll get more into the perfect measures and how they lead to essentially perfection. So by idealized measures, each side of a pyramid is 440 cubits. Therefore, you stand at the corner, you see 880 Egyptian raw cubits. The height of a pyramid is 280 Egyptian raw cubits. So 880 divided by 280, you can reduce that to 22 over 7, which is the best, well, one of the best whole number approximates of pi, 3.142857142857. In modern engineering terms, if you were to get a building at 22 over 7, you'll be doing extraordinary by the modern. You'd have to really be in a high-tech lab working with high precision equipment and highly precision components for high precision and space age really type of stuff to get it above 22 over 7 to need it at that ratio. So this 22 over 7 is equal to or above modern engineering standards on all but the highest scales. So back to the relationship, meter plus Royal Egyptian cubit plus the foot being 6 foot, or this 5 feet to 6 feet ratio, as in 5 being 5 over 6 times pi, essentially being 5 over 6 pi being phi plus 1 or phi squared meters, therefore 5 to 6, which is also in the Great Pyramid, because the maximum visible height of a pyramid is 280 Egyptian royal cubits, yet including the subterranean, the below the surface is a 6 to 5 ratio, 336 to 280, which is an important feature, and we'll link because 880 Egyptian royal cubits being the maximum visible base length. The most you can see of a pyramid is 2 sides, including the maximum, let's just call it invisible height, being 336 Egyptian royal cubits. Well, 880 divided by 336 equals 2.61904. So just like the maximum visible base length divided by the maximum visible height gives us essentially pi, the maximum visible base length divided by the maximum invisible, including the invisible height, gives us phi squared. Now if we include the slight variations in insight, so I'm using the idealized measures here, but we get much closer to perfect pi, we get much closer to perfect phi plus 1 or phi squared. We also get the golden number in there. We'll be examining that later. But so 5 over 6, 5 over 6, 5 over 6, giving us also phi plus 1. Okay, which brings us, so I'll go through these again in the future. I'll do a whole review of this series, but what we have is, for instance, the red pyramid. If you were to unfold the red pyramid down, what you would have is you would essentially form 4 pentagons, or the essential geometry of that, at 43.22 degrees, ever so slightly, and it just so happens that both the red pyramid and the bent pyramid are 200 Egyptian royal cubits high. Menkaura's pyramid is 200 Egyptian royal cubits on the base at its longest side. So 200 Egyptian royal cubits wide, 200 Egyptian royal cubits high, 200 Egyptian royal cubits high. The red and the bent pyramid are at the same height. However, the top portion of the bent pyramid is at the same angle as the red pyramid. So the top portion of the bent pyramid folded out would create a series of pentagons or pentagrams. And that leads back to the golden number. So mathematically speaking, to get perfect phi is really, it's square root of 5 plus 1 over 2, which is basically on to infinity, a number of decimal points. But geometrically speaking, the pentagram of a pentagon is a perfect representation of this golden number, and even the angles in trigonometry leads to variations of the golden number. So the red pyramid and the top portion of a bent pyramid also relate to the golden number, as does the great pyramid. So the slope to the half base is a ratio of 1 to phi, which is built into nature. So we see a series, so whether it's the pentagram or the pentagon, the golden number links 1, 2, 3. So the pyramids are all linked in multiple ways, beautiful ways. Now consider the bent pyramid. So now 5 over 6, as is the great pyramid. Well, the bent pyramid, the top portion, if you were to fold it out, would create a series of pentagons or pentagrams, 5-sided or 5-pointed stars. The bottom portion folded out would create a series of hexagons, 5 to 6. The same relationships. Each of the pyramids is beautifully, wonderfully linked. Previous episodes I went into this, and we'll do a review towards the end, but this essential Euclidean beautiful geometry, ratios, systems of measurement join all of the pyramids together. It really is exquisite. So I'll do more in the future, but what we have is using the actual survey. No one side of a pyramid is exactly 440. Each side of a pyramid has a slight variation. If you include the slight variations, this close approximate of pi approaches perfection. This close approximate of phi plus 1 or phi squared approaches perfection. And so that's the imperfections of a pyramid actually lead to these perfections. So these very close approximates, if you include the alleged construction errors, leads us to beautiful perfection connections between these aspects. So now using the idealized measures, so we have the south and the eastern base. So this is the southeast corner of a pyramid. So I've just highlighted it there. That would be 1,511.954 feet. Now, why is that important? Well, one Egyptian raw cubit equals 1.717843,752 English feet. This is a relationship between the Egyptian raw cubit and the foot. Now we have Euler's number, which is E. This is an important mathematical constant as well. So whether it's phi or pi, these are ultimate truths of the universe in that they're mathematical geometric constants. And the Euler's number, now that's how they fit. So it's 1 over 1 plus 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, etc., etc. Now, why is that important? Well, I'll put the link into the number file because there's a bit of poetic license to get Euler's number. So the actual sequence is that there's a beret-wearing philosophy to it to get this thing, and that will be in this number file video. I'll try to remember to link that. But what's really happening with Euler's, it's 1 plus 1.71828,183, which is 1 plus 1 divided by 1 factorial plus 1 divided by 2 factorial plus 1 divided by 3 factorial, etc., etc. And this 1, okay, so that's Euler's number, 1 plus, okay, which we have there, and there is 1.717843,752 English feet per Egyptian raw cubit, which is a difference of 0.0084431 feet, which is 0.257, etc. millimeter. So now we're talking about 1.5 human hairs of margin of error between E, or 1 plus this, and the ratio between the foot and the Egyptian raw cubit, mathematical constants. Now consider again the golden number, phi. Phi squared equals 1 plus phi. 1 divided by phi equals phi minus 1. This plus 1 minus 1 thing is, well, it's a beautiful little thing that's connected into so many other mathematical geometric constants. But that's like an example of the golden number and how phi squared, or phi plus 1 equals 2.618, etc. 1 divided by phi equals phi minus 1. Only happens with this number, but also the links in other aspects, such as Euler's number in a relationship between the Egyptian raw cubit and the allegedly modern English foot. So Euler's number, or the number of English feet per Egyptian raw cubit, well, 1,511.954 feet equals 17181.2, etc. long inches. I'll link in the description a series on the long foot and how it is a harmonious point between multiple sets of ancient measure. This is what's happening. Multiple sets of allegedly unconnected ancient measure, these unconnected civilizations in their architecture including the same ratios, and it just so happens that their units of measure link geometrically, mathematically, astronomically together. The level of probability is infinity minus 1 that these just happen to fall on these perfection, and even the margins of error containing higher levels of information. Just really extraordinary stuff. In regards to mathematical constants, I'll also link this in the trailer, CPAK Alan Green trailer, because the more than phi, more than pi, more than phi, more than Euler's number, the Great Pyramid contains multiple mathematical geometric constants. And well, math and geometry is universal. Math is universal. It is the one true universal language which everyone must speak. Nature insists on it. So whether it's Euler's number, phi, pi, or the geometry of hexagons, as in the seed of life, this is not some kumbaya religious thing. This is a fundamental truth of the universe. And so whether a million years ago on Earth, or whether a million years ago or a million years in the future, anywhere else in the three-dimensional universe, this is a fundamental truth. Pi is a fundamental truth. Phi is a fundamental truth. And so with Euler's, and as some of the other constants, which will be mentioned in this particular video by Alan Green. It really is a beautiful, coherent, lovely system. Universal truths. This is the what's called the Cat's Eye Nebula, and I'm just showing that one because it's basically it's a vesica. Now, over time, that's going to change, but it's just at least as an illustration of considering the eye and this geometry, which is universal truth. In our, especially our, the the disinformation age and the political age, hyper-partisanship, everything that's going on with relativism, this truth is only relative in regards to someone else's. No, there are certain universal fundamental truths, and geometry and math is one of those. And it's and these constants, these ultimate universal truths are built into not just the pyramids, not just how the pyramids relate to one another, but also in other ancient architectural sites across the world. So Karnak, France, stone circles, all across the Mediterranean, ancient India. I also find them in Mesoamerica as well. And so each time the probability increases to a level of it really almost is a religion to say that this is coincidence, or at least that it's not a curiosity worthy of investigation. These are mathematical universal geometric truths. They are repeated. They connect through systems of weights and measure. And just like now, so recently the kilogram was redefined to put it to a mathematical universal constant. And it just so happens that these ancient systems and this ancient architecture, which embeds proportion, but also metrology, measurement, also repeats consistently this geometry, this math, universal truths. Lots more to come in regards to weights and measures and how the meter, the foot, the cubit, and the Doric, the Ionic, and the long scale blend together to ancient units such as the Mohenjo-Daro, through the pendulum and time, physics, math, geometry. It all comes together. Call it coincidence if you like, but that's essentially it's denialism. Let's be frank, because if the maths and the geometry is pure and it's true and it's repeated, whatever you need to believe to sleep at night, but here's the evidence, it's repeated. Done a lot of other videos on other ancient sites, lots more to come on other ancient sites, and it is consistent. With that, hope you enjoyed and have a good one. The truth shall set you free.